Hello everyone, I'm Harsh and I will walk you through our project NeuraNFT, an application that will store your AI in a decentralized way. So before starting any decentralized application, we have to authenticate it with the blockchain it's based on. In our case, it's ICP. So we will create an internet identity to authenticate ourselves on the blockchain. After authentication, we will be redirected back to the main page and then we will be able to see an account address, meaning that we have been successfully authenticated. After authentication, we will see a drop menu showing our NFT collections and an option to create an NFT. I will demonstrate you how a user could create NFTs in an application. I'll make a knowledge base having my resume as a reference. We are seeing a success message, meaning that an NFT has been created. Now we will be able to see our created NFT on the collections page. Now coming to the collections page, in order to chat with the NFT, we will have two options. First is through the application UI, and second using an API-based method. I will demonstrate the chat UI first. Here we get some information about our NFT, and once our model is loaded, we can chat with our NFT. As I uploaded my resume as a reference, I'll query. The query will be sent to the HPC nodes, and then the DIDB vector client will search its database to get similar remedies. After that, the model will generate an appropriate answer. Our chatbot has some context window, thus it can infer from previous query to get new answers. Now coming to the API path. When I click on the API button, the backend will generate an API key, which will be passed to the user. I will demonstrate this on the Python notebook, but we can also use the curl command to call this API on terminal. I pasted the API key and the endpoint here. We have designated routes in the backend for API calls. On the first endpoint, the backend will verify the authenticity of the API key, and if it is authentic, it will return a JWT token with a URL where our base model is hosted. In the second endpoint, we will pass a query with the JWT token and the URL. If the JWT token is verified, the model will give the appropriate answer. After giving a high-level overview of the project, I will explain how we are using TIDB to store and retrieve embeddings efficiently. We send HTTPS request having our documents to the backend as we want to vectorize the data into embeddings, which is done by Llama index, and then we store the data in TIDB. We are only storing the vector embeddings in TIDB, not the document chunks, as we want to securely store our documents inside our NFTs only. We add a document identifier, which is a random string, to every embedding before adding it in the database. We do this because while querying, we can filter the search efficiently for that particular document only, rather than searching the whole database. The main reason why TIDB benefits us in our use case is the vector search time in TIDB is significantly faster compared to most databases. It's highly scalable and it provides strong consistency and high availability in distributed environments. We're using Llama Index because it simplifies the integration of LLMs with external data sources and it offers flexible data connectors for various storage systems and formats. It also provides advanced querying capabilities, including semantic search and multi-document synthesis. Now I'll do a quick walkthrough of our code base. Here we get the HTTPS request to insert the vector embeddings inside a database. As you can see here, we make a random string as the document identifier and add it in the database for retrieval purposes. Now in the chat route, we're using the identifier as a filter for making the vector search efficient, thus helping us to get a quick response. Here you can also see how Llama Index is used extensively for LLM initialization and vector embedding generation, thus making the whole process efficient. Now I've come to the end of our presentation. Thank you for your time.